In this example, we're going to find the volume of a solid. We're going to be using the base as the first quadrant of 16 minus x squared, this parabola here, this curve in green. The x-axis is in red and the y-axis is this line in green. So our first quadrant, which is going to be our base, is what I am highlighting here in yellow. Now, we're also given that when we find the area by slicing, these slices are going to be perpendicular to the xy plane and that the slices are going to be squares. So when we say perpendicular to the xy plane, that means it's going to come up this way and pop out of the xy plane. And that's what's going to make it 3D. And since our slices are going to be squares, when we find the area of the slice so that we can integrate it over the interval that we're interested in, I know that my length and my width of the square are going to be the same, so that makes it even easier. So imagine that I'm making a slice here, and I'm going to try really hard to make this look as realistic as possible. Here is a square that's popping out, and not too bad. So this square right here is one of the slices of our solid that we're trying to find. As we move from 0 to 4 along the x-axis, those slices are going to change size or an area. So when we write our slice as an area, to integrate it, we have to make sure that we write it in a generic way. Look at specifically this edge of the square. That's the height of the function. So if I plug in x equals 1 into the function 16 minus x squared, that will give me the length of this square, and then I also know that it's the width. So when we define our cross section, it's going to be 16 minus x squared times 16 minus x squared. I'm just going to write it as 16 minus x squared squared. So when we find the volume by slicing, we need to integrate the area of the slice over the interval of interest. So the interval that we're interested in is the interval that defines the area under the curve in the first quadrant. So that's going to be from here to here. So that's 0 to 4. So when I write my upper and lower limits, I'm going to write it as 0 to 4. So what we need to integrate to find this volume then is 0 to 4 of 16 minus x squared, squared, and then dx. So this is going to give us the volume of the solid that we discussed.